So we're going to add and subtract today. Add and subtract requires that you have a common denominator. So the first thing you have to do is see if your denominators are factored so that you can get that common denominator. In this first example, the polynomials are already factored, so our common denominator has to be the x plus 3 we need for the first and the x minus 5 that we need for the second fraction. And so now I need to multiply each fraction by the part of the common denominator that it's missing. So that first fraction is going to multiply by x minus 5. And here's what's critical. I have to remember that if I'm changing the bottom, I change the top in the exact same way. That way I'm changing the fraction by something that's equivalent to 1. Alright, the second fraction has the x minus 5, but it's missing the x plus 3. Okay, so now we're done with the bottom of the fraction. The bottom of the fraction is the common denominator for the rest of the problem. So x minus 5 times x plus 3, while we work on figuring out how to add, and therefore add like terms of this numerator. Okay, so I really want to undo that. Let's see if it'll let me undo. There we go. That obscured that more than I wanted. Alright, so we're going to distribute, we're going to distribute to accomplish the multiplying. So we're going to get 2x squared minus 10x. And then over here we're going to distribute as well. So we're going to get plus 6x plus 18. And then now that we've finished the multiplying, we'll actually be able to add, since this was an addition problem. We will add like terms. So we'll have 2x squared minus 4x plus 18. Okay, so we've done everything except for seeing if the fraction simplifies. You know, if you come up with a 3/6, you would simplify that to 1/2. So is there some simplifying that can be done here? Well, to find out, we need to look and see if the numerator can factor. We left the denominator factored, so we're good there. Looks to me like a 2 can divide out of the top. There's a greatest common factor of 2. So then we'd have x squared minus 2x plus 9. And I can ask myself, now that a equals 1, if there are two numbers that multiply to 9 and add up to be negative 2. 3 and 3, 9 and 1 do not add up to negative 2. So that is as simplified as my answer can be. Okay, what about subtraction? Subtraction is different because of that very first step. If you see subtraction, you right away need to add to the opposite of the numerator. So I'm going to distribute this negative to the 4x and this negative to the 4, and I'm going to change it to an addition problem now. Alright, so now I have to get a common denominator, so I need to factor what I have. A times c here would be 6. So the two numbers that multiply to 6 and add up to be 7 are 6 and 1. So I'm going to trade out this 7x for 6x plus 1x. And then we're going to split it down the middle and take out our common factors since we're doing AC method. So we'll take out 2x, which will leave us x plus 3. And then on the other side, I already have x plus 3, so I'm just going to say I take out a 1. So the factors of the first fraction are 2x plus 1 and x plus 3. Okay, so we have two factors so far. Now we move over to x squared minus 9, and that's x plus 3 and x minus 3, because it's a difference of squares. So my common denominator this time would be everything in the first fraction, so 2x plus 1, Well, why won't this write? 2x plus 1 and x plus 3. And then compared to the second fraction, I already have an x plus 3, but I need an x minus 3. So those are the three building blocks of my common denominator. So now I go to each fraction and I compare and find out which one's missing. The first fraction has the 2x plus 1 and the x plus 3, but it needs the x minus 3. So I multiply that in. And the second fraction has the x plus 3 and the x minus 3, but it's missing the 2x plus 1. So I multiply that in. Alright, now this is going to be a little harder to multiply than the distributing was last time because I have a binomial times a binomial. So I'm going to have to FOIL here. So let me get my fraction ready to go. Get my common denominator ready to go. X minus 3 times 2x plus 1 times x plus 3. And FOILing begins. So x times x, I'll have x squared. X times 1, I'll have 1x. If it helps you remember there was a 1 there, draw the 1 in. Negative 3x and negative 3. Now the like terms on the other one. Negative x times 2x, we'll have negative 2x squared. Negative x times 1 would be negative 1x. Negative 4 times 2x would be negative 8x. And negative 4 times 1 would be negative 4. So now I search for my like terms so that I can accomplish the adding that was wanted in the original problem. Alrighty, so x squared minus 2x squared, so negative x squared, or negative 1x squared. Then we have 1x minus 3x minus 1x minus 8. So 2x minus 9x, so negative 2x, so negative 11x. And then lastly, negative 3 minus 4, so negative 7, minus 7. A times c would be negative 1 times negative 7, so 7. I asked myself if anything multiplies to 7 and can add to negative 11. There is nothing, so I know that's the end of my problem. So there's an example of a pretty tough subtraction problem.